Am I back now? Says I'm back. Yeah, I don't know what happened. OBS crashed. So, but we're all back now. Okay, so back to this. So let's see here. This is that I2C extender chip. Let's see, 3 to 12 volts. Let's see. Okay, it can drive up to 30 milliamps, but it doesn't tell me how much it actually draws. I only have a few in there, Spoon. Honestly, there's only 3 that I'm really paying attention to anymore, and I've actually thought about leaving those other ones. Okay, so this is all nice. This tells me how to assemble it. This tells me how to do it. $300 milliwatts is what that thing takes. So, okay, 15 milliamps. So, okay, so I didn't see who followed. Thank you for the follow. Let's see. Piano Master, what we're working on is I'm working on some lighting for well, here, let me show you. I'm working on some lighting here, you can see it, that is controlled by a Pi. That I can then go do things like, let's see, so I can flash it different colors, and then I can make it do swirly patterns. Okay, Piano Master just followed, so thank you for that. And then it's got a little idle animation. Okay, yeah, Jinx. I finally found it in the spec sheet. Right there. Well, that's at 12 volts. It's 15 milliamps. So yeah, so we're looking at about 60 milliamps for that chip alone. This is the spec sheet for the bus extender. Oh, that's always fun, Piano Master. If you go look in the description below, or in my little tiles below is my YouTube channel that I've got all that. I actually have all of me building. It's not an RGB one, unfortunately, but it's a regular LED cube that is 8 by 8 by 8. So my 8 by 8 by 8 cube. And this was another project I was working on that I abandoned. I'll get back to that one eventually someday, maybe. I don't know. Okay, yeah, so we're at 740 now. And then, let's see, let's go back here. I ditched the R clamp because it shorted out and blew up. I originally had these guys on there for ESD protection on the I2C bus. But as soon as I hooked it up, it burst into flames and shorted out and killed a couple of chips. So I'm like, okay, I'm not going to worry about ESD protection. I tried to make it right. Alright, what's the other chip? That's the voltage regulator, spec sheet, capacitor, capacitor, capacitor. Is it? No. That's the heat sink. Is it this one? Nope, that's the LEDs that I'm using. That's the connectors that I'm using. You know what? Give me a second here. I'm trying to think which screen I need here. We'll just flip to that one. Oh, the LED cube is actually completed, piano. It was that other board that I've got. I was trying to build my own sprinkler controller. Let's see, which chips am I using? I'm using an STC Micro that was pre-programmed because I bought this as a kit. And it is using the... I can't read the chip. Ah! And I just bent the pins. These are the 74HC 573s to turn the chips on, LEDs on and off. This lighting project that I'm doing is kind of my first foyer into designing and building my own electronics. Prior to this, I was mostly doing just assembling kits and things. And, you know, getting like jelly bean off-the-shelf parts and sticking them together and making them work. This one... yeah, this LED cube, I actually got it off of Amazon. So these are the SN74 HC 573ANs. Now, like I said, with this LED cube, I can't take all the credit. I bought that one as a kit. So... So what I'm doing right now is I'm logging into Mauser because this is where I ordered all my parts from, but I didn't want you guys to see my address, so connectors. That one wasn't it. $288 one. There we go. Automotive connector, multi-layer, interface, signal buffer repeater, ESD suppression. Where are you guys? Ah, there you go. The MCP. Alrighty. So let's flip this back over so you can see it now that I don't have my address up on screen. So this is the chip that I'm using for the I/O interface. It's an I2C 16-bit. You know, basically, you send it commands and it, or you write to buffer registers and it outputs according to the pin. So you've got group A and group B, and each one's 8 bits. So you'll write an 8-bit to group B's, and the corresponding pin will go high or low. So here's a block diagram of it. So this thing, $700 milliwatts at 5 volts. Okay, so I'm having a brain fart here on how to calculate that. And then, yeah, okay, so it's 700 milliamp or milliwatts. Watts equals volts times amps. So I need 700. Oh, clear. Decimal. 700 divided by 5. So that's 140 milliamps times 2 is 280 plus the 740 that, yeah. Well, I've got 2 of those chips on there, Jinx, so add another 140 to that. So yeah, we're just over an amp if I have all of the lights on at the same time, which is why my voltage regulator is heating up like it is. Which is why I'm going to order new ones. Because if you can see, I have these sitting in my cart. I just haven't ordered them yet because I haven't had the money. They're 5 volt at 5 amp. So the main reason I'm getting the 5 amp one over just maybe say a 2 amp one is because the Pi itself will need needs that much. Boink. Because I plan on powering the Raspberry Pi off of that too. Did my... Okay, I must have closed the VNC. So yeah, the basically I'm not gonna have the USB connection here powering the Pi. The Pi is gonna get powered off the 12 volts as well, and that's what this voltage regulator's for. Oh, you can't even see that because that's off screen. So yeah, the voltage regulator, it's not currently installed, but the voltage regulator that's going there is going to be a 5 amp one, so it's enough to power the Pi. Yeah, see, and that's what I'm thinking. Is it's getting so close to its maximum threshold, Jinx. I mean, it's probably they say 1 amp probably plus. I'd have to look at the spec sheet, but I believe with the 7800 series voltage regulators, it's 1 amp plus or minus 10%. So on a 5 volt regulator, or yeah, well, on a 1 amp regulator, that would be about 1100 milliamps that it could do with it before it fails. But you're right, once I get over about 900 milliamps, that's when it starts getting into its very inefficient part of its curve. Its most efficient part of its curve is going to be about a 70 or an 80% load on it. And that's where it's going to be most efficient. Now, granted, I'm going to be throwing efficiency out the window by going to a 5 amp one because it's going to be way down in the efficiency band. But I'm not going to be generating as much heat because I'm not dissipating, or I'm not pulling as much current through it, and so therefore not generating as much heat because I won't be dropping as much across it, as much wattage. Again, but other things have come up, like my wife's car has a bad alternator that I need to fix, so buying more parts for this project has just gotten bumped even further down the list. And I dropped my cell phone the other day and cracked the screen, so that needs to get replaced before I buy new stuff for this project. So I figure it's okay for me to test right now with it, but when I get this actually up there on stage with people at my church, it's not gonna fly having it overheat. Yeah. Oh, and Piano Master and Quibla. I did actually attempt this earlier, but I screwed up the measurements on my board, so I had to get new ones printed. So I don't know how I screwed up the measurements on that, but I did. Yeah, that is very true, Jinx, that it could be pulling that much, and that's why the heatsink's getting as hot as it is. Like right now, I'm probably pulling, let's see, 140, 140, 280, 280 plus another 60. Let's see. So that's 3. And then another 400 for, no, another 80 that for that. So yeah, I'm pulling about 380 milliamps through it right now, and this heatsink's stone cold. Because yeah, each one of these is 20 milliamps. Then I got the 140 and the 140 and the 60. So that's 300. 300 for that, 380. 380 milliamps, and it's stone cold. But I start doing other things like, I start doing that. I mean, it gets warm while it's doing the blink tests and stuff. But I mean, it doesn't. It's not too hot to touch. It's only when these outer LEDs, if I turn them on high intent, or if I turn the outer LEDs on, that it gets super hot. Super hot. Anyways, I've actually been streaming for about 4.5 hours. I was actually gonna call it quits when Piano and Quibla came in. I thank you too for the follows. But yeah, I've gotten this to where I can do more work with it. Oh, that's right. Yeah, I'll have to look at the spec sheets on it, Jinx. Actually, do I still have it up? Let's see. Do they? Does Texas Instruments still give you the power curve? Yeah, I'm getting it in the TO 220 package. Oh, you buggers. I just noticed I can't use these. I'm glad I looked at that. Because my pinout on my board is input, ground, output. I mean, I can probably do something to make it work better. Why do you... yeah. Okay, so here's the efficiency curves. Dropout voltage, short circuit current, frequency, load regulation. This one's actually got a pretty flat... Oh, that's over temperature. Ripple rejection, temperature stability. Ah, load current. Yeah, you're right. So... That's not the one I want. Adjustment pin current, temperature stability, frequency, input, output, differential voltage. Yeah. I'm not sure which characteristic curve it is, but yeah. I'll have to dig through it. But anyways, yeah, I just noticed that my pinout's going to be wrong if I get these. I wonder, can I run... Can I run the 7805s in parallel for extra amperage? I've never done that. I'll have to do some digging and see if I can find a better amperage a better amperage one that's within limits. Oh, you guys can't see that. But anyways, like I said, I was gonna quit out, but yeah. So yeah, I just noticed that, you know, they're different here. The ones that I've got are, let's see, input, ground, output on my pinout, instead of ground, output, input. Why does Texas Instruments have to be different? Ugh. Anyways. So. Where did it go? Thank you all for joining me tonight. It's been fun. Thank you, Jinx, for helping me out with that bash scripting. I might still use some of that. The Python script, it seems to also be working now. I just got to now figure out how to have scripts execute remotely or something. what I'm thinking about doing is maybe doing like an MQTT broker or something. I am not 100% sure how I'm doing it yet. But basically, I want to be able to, from another end, trigger certain animations. But that base light test script will now allow me to basically, I'll just have to copy and paste it and write scripts that I need. That is a thought too. But one of the guys is providing a what is it? The Asus Maker Studio or whatever. That's basically the Pi with the touchscreen attached to it. And that's going to be controlling both sound and light. So there's audio that goes along with these. In fact, actually, I think I still have them here. So, give me a second here. Yeah, because I've got sounds that go along with it. That I've got to animate to, if I can find what I did with them. What did I do with them? Okay, I know how to get to them. Okay. So, one of them is going to be... Where did you go? Where did you go? Where did you go? So this is what one of the sounds is going to be. That I got to animate lights that go with it. And then the other one. This is for when something goes wrong. Then we're gonna have a smoke machine and stuff that goes with that too, so. But yeah. RPC, so yeah, I gotta look into it and see what I'm gonna be doing. Jinx, I haven't quite decided. The big thing was get a Python script to control the lights. Once I got that, then it's, okay, now how do I control the Python scripts? So, one step at a time. But again, thank you all for joining me. I am actually going to do something. He's doing a silent stream right now, but he is a... Let me double check and make sure he's still there. I know he was doing a silent stream here. Yeah, he's still going. He is the one that basically got me to do the get up the nerve to stream. So we're gonna go ahead and read him. Or whoops. How do I do this? Raid short. I don't know if I can even do that. Yeah, I don't know how it's gonna work, but I'm going over there to watch KB stream. You're welcome to join me.